Hello, my everybody's. Welcome to Futurism with Gretchen. Today I'm going to be talking about nothing less than immortality. Yes, it is possible, and I will explain thoroughly how that'll happen over the next however many years. To start out with, I'd like to discuss something called BCIs, brain computer interfaces. Basically, they're able to connect these devices to rats' brains for now. They have successfully been able to understand some of the signals that come out of the brain. You know, when the rat is in distress, when it's kind of happy, when it's all these other different things. They can even control the rat's motor skills or kind of push it to the left, to the right, get it basically have it behave like a robot. That's just the beginning of it. Everybody knows Elon Musk nowadays, right? He has a company called Neuralink, and his product is currently the front runner in that whole BCI thing. The real thing with that is he doesn't just like hook up like one or two or three electrodes to the brain. His product is actually a robot that is actually able to mass implant, let's say, a 10 by 10 or 100 by 100 matrix of electrodes. That opens up the possibility of being able to uh, read somebody's visual cortex to actually see what they're seeing. When somebody's dreaming, the same part of your brain is used, the visual cortex. So, yes, you could actually watch people's dreams. Right now, they've only done tests on sheep with their product, but it's not limited to that in the future. As the data density goes up, you know, we'll be able to get full HD videos into our brain just directly. No screen needed. You'll just have a little heads up display that kind of sets a certain picture. So replace all your monitors, all your phones with a little heads up display that's actually not even attached to your eye, not doing anything. It's just being fed directly into your brain. Same thing with auditory signals. Same thing with pretty much any other signal you can think of. But that level of complexity is probably not going to happen, especially not in humans, for another 15 years or so before the FCC allows that sort of testing. At first, it's going to be used on patients who have been paralyzed or have some kind of a horrible disease that they can't use their hands or feet or anything and need some way to interact with the world. That's going to be the first case usage, probably about 15 years or so. Um, I myself am looking forward to that sort of thing. I would love to have a little virtual keyboard in front of me that I could, with my brain, that I could use and talk to computer, mouse, joystick, whatever the case may be, and add an HD display of some sort into your brain and some sort of stereo audio, put it in. You got yourself a complete entertainment center right there in your brain. All you can do is tell your phone or whatever other device you have to just send a stream of data, and you'll be getting that information. Some of you are going to wonder, yes, that there is an issue with these streams being hacked or whatever. They're not going to be able to change your mind, to change your thinking, anything like that. Even if they did get in, cryptography is getting really kind of crazy. Yes, it's true with quantum computing that they can break a lot of these cryptographies right now. But the distances that these brain computer interfaces work at is so tiny. It's the electrical signal basically only can travel about that far. Kind of similar to an RFID. Um, you're gonna have to have some kind of a transceiver or something to connect back to your phone or whatever other device, and you can firewall the hell out of it at that point. So that's not going to be a giant issue. It's possible, but very unlikely. So that's kind of the first step. The next step after that, they will be able to scan the brain. Not sure how. That's kind of still up in the air. Nobody knows for sure how to do that sort of thing accurately. With MRIs, you can get close, but nowhere near the level you need to recreate a virtual brain. That's going to be the tough part. Whether it's going to be in conjunction with some kind of a nanotech devices, or just plain scanning through an MRI with like super crazy um, resolution. We'll see how that goes, but it will be possible. But yeah, the brain scanning is going to be the most difficult part. At first, we're going to be testing on rats, rabbits, monkeys, dogs. You know, at the moment, we can fully simulate a C. elegans. That's a nematode, roundworm. We can simulate every neuron in its body, every muscle, everything. But going anything past that is kind of difficult. Next step would be trying to simulate a bee. A bee's got one of the largest synapse counts in the world for insects. Um, Lizards. Then we can go up to mice, and it's going to be a progression. And for in going in that direction, um, currently IBM is working on a artificial intelligence chip called True North that works very similar to the way a brain works, and it will be able to maybe not the True North exactly, but a chip like the True North will be able to simulate these roundworms, insects, rats, whatever the case may be, their brain, attach all the correct inputs to the right places. Inputs meaning cameras, eyes, um, the actual signals that go in are very different to what we're used to. But we are starting to understand this language of the brain. Instead of having electrical impulses, they call these different signal spikes. They vary by amplitude and frequency and all that sort of thing. But yeah, I think basically analog signals with a few different properties. But they're able to simulate that pretty well. They can get about 4 million or so neurons worth per chip. The human brain has about 1 trillion or so neurons. So according to Moore's law, we should be able to get to that about that level in about 40 years. We'll have the hardware required to be able to simulate a brain as big as a human brain. At the same time, we are also working on artificial eyes that can send a signal to your brain that is virtually identical to that of an actual human eye. It's very bulky at this point. The resolution that it can capture and send is not that great, but that's improving all the time. I don't know what the actual number is. I'm not tied in that closely with those projects. Well, I'm not tied in with them at all, but I've been keeping an eye on them. With hearing, it's also a little bit different than like computer interfaces. In the human brain, or well, let's stick with mammalian ears. You have the cochlea, which is a spiral tube that allows the audio to resonate. And along that, you'd have these different hairs that vibrate with different frequencies. So basically, if you convert the audio into these discrete lists of frequencies rather than just straight audio streams with samples as is done on computers, which is actually easy to do using Fourier transform. But yeah, just send that over in the right format, the right rate of transfer, which is real time. Um, then should have hearing pretty much covered. Same thing with any kind of sensory issues. Um, it could all be simulated. That's being worked on for people who are blind, people who are deaf, etc. So I don't think they have any. There have been some human trials with that sort of thing, actually. But yeah, we have a pretty good idea of how these sensory systems work, and we know how to tie them to the brain, and we are learning how to interface with the brain. We've been able to simulate full brains of organisms. We just don't have the scale down yet, or the scanning infrastructure. That's really the most critical thing. Having that scanning infrastructure is very difficult, especially for something as big as a human brain. Um, we can probably do a rodent or insects or whatever without too much hassle. It's probably very expensive now. Like DNA sequencing was 40 years ago. It was a very difficult thing, and now we can do it pretty much in 5 minutes. It's not a big deal now. Whereas back in when the first human genome was sequenced, it took years upon years. We're kind of at that point right now with scanning the human brain. We've been able to get the structure to a point, but not anywhere near enough of it to be functional as a whole. Um, but yeah, the big the big trick will be the scanning. Whether that's going to be using the BCIs of some sort, or some sort of fMRI, or something we haven't discovered yet. That's that's the part that's going to be difficult, but strides are being made every day on that sort of thing. I have no doubts that we'll figure out how to do it pretty soon. Uh, they've been able to do that C. elegans no problem. Getting a rat, they could probably do that fairly easily, but not it's not trivial, but it's something they can do with some effort. And the scale of it is it's expanding, and it's getting bigger, and it's nowhere near to get a dog or a cat or anything big yet, but it will be in the future. I'm guessing about 20, 30 years before you can get like a simulated dog brain, for example. Um, and that dog brain would be pretty much identical to the original dog. Same behaviors, same memories. All the memories will be saved. All the everything will be saved. And once that's done, yes, you could transfer those memories from one person to the next, or from one dog to the next. Same thing with human down the road. And within about 40 years, 40 to 50 years, I'm kind of I'm kind of shooting for 40 based on my understanding of Moore's law and all that. We will be able to do the same thing for humans, and humans at that point will be effectively immortal. At least that's in some form. People are gonna yell and scream about whether these people are truly alive, whether this or that. But think about it this way: if If you go the route of replacing little bits of your brain at a time, if you remove a part of your brain that is used to hear, for example, and replace it with something artificial that does the exact same job in the exact same way, would that be the same person? If they replaced a little bit of the memory centers of the brain with artificial things, and a little bit at a time, would they be the same person? You go on and on and on. At one point, are they no longer the same person? At one point, are they no longer alive? Um, the data is all there. The data is all consistent. The only thing that's changed is the substrate that's using it. But that's going to be a huge, huge moral argument, legal argument. Are these people really alive? Are these people, do they deserve rights? Can they fight against being turned off? You know, nice thing about being turned off is when you are in that kind of substrate, turning you back on isn't a problem. Your parts don't degrade. So yeah, effectively, you are immortal at that point.